So we end up just getting what this is. This is really just y hat. And we use that to predict y, right? So that's really all a neural network is. It's a set of linear models for, in this case, that are different in hidden layer 1, that are then used to maybe combine again, or maybe just leave where they are, and then combine together in some form or fashion to give you an output. But this is, at its root, is a computer science created type of thing. This isn't really a statistical thing that was created. It's more was created from computer scientists. And so the way that they get at their answers here aren't the way that you've been using to get your statistical answers for your regression parameters so far, such as least squares and that type of stuff, right? They use computer algorithms to get to these answers. So the weights, those are the values determined by an algorithm to either strengthen or weaken the input or the hidden layer node it's applied to. Think about those as the beta parameters, okay? And they're happening at each line. Each line, so x1 here gets a certain weight multiplied to it. For this node, it gets a different weight for that node, a different weight for this node, so forth and so on. And the computer figures out what all of those need to be. There's this thing called a bias weight. That's basically just a intercept. And that's it. There's some more stuff. There's a thing called an activation function. Basically what that does is, because we have all of these models, we have in this case 4 models that we're producing, right, in the first layer. We don't want them all to be weighted evenly. We don't want them to all get the same. For instance, if this model all gave a bunch of small values, we wouldn't necessarily want to trust all those really small values, because what happens when you add up a bunch of really small values? You get a big number, and that big number could end up not being true. So what the activation function does is it tries to manipulate the number in a way that is useful to us. I'll just put it that way. There's an algorithm that determines what the weights and the biases needs to be, and they're called forward and backward propagation. And there's this thing called gradient descent, and it's real fancy, and it's not something I'm going to go into, but basically it's an algorithm that's used to come up with these weights and biases. There's a thing called an output layer. Again, that's your y's. That happens on the right. That's where the predictions are made. There's also a thing that is useful in the determination of the weights and biases. That's called a loss function. And that loss function you can think of like least squares. It's trying to minimize that loss. It's trying to make sure that the errors that happen within the model are small, so that our predictions are accurate. Right? So here's an example all kind of spelled out with all the weights. So here's a 3-layer, we have 3 inputs. Each one gets multiplied by a weight. And then they are, each one's called beta 1. They're applied to this activation function. And you can see all the connections. So this is what's happening inside of a neural network, so to speak. Kind of a black box, right? Probably not going to go in there and probably understand what all these mean. So when is it good to use a neural network? Well, a neural network is really useful in almost any type of data situation where you have continuous or categorical outcomes, which is everything, and for the most part. And so, you know, one of the places it's been most useful is in image classification. So when you go to Google and you type in dog, a neural network is determining which pictures were dogs and which were cats, and it populates the dogs. But the real usefulness of neural networks is that it's robust to many types of inputs and patterns. So maybe you know nothing about your data, right? But you know you have a response, and you want to be able to predict that response. Maybe it's cancer. Maybe it's whether or not a cell is going to turn out to be a certain type of cell or not, based on various things, or whether or not, just think of whatever you would want to predict, and basically a neural net probably is going to do a pretty good job at doing it. Where there's little known about the relationship of the inputs and the outputs, neural networks are often very useful. So again, maybe you know nothing about, you have lots of variables, lots of data, and you're like, you know what, I don't know anything about any of this and how they could be connected, but I know I want to predict this one thing over here. Let me just let the neural net figure out what it needs to be. I'll set it up so that it can go out and run and find whatever might be out there. Kind of sounds like the holy grail of regression techniques. You really don't need to think about what you're doing, right? But there is a lot of, for the harder problems, there is a lot of art to this. And also there are a lot of downsides to this, which we'll talk about at the end. So let's move on to the example. So I want you guys to go ahead and open up that jump data set that I sent you. This is a really cool data set that I actually, with some of my undergrad student workers, we mined the data. So is everybody familiar with IMDb, Internet Movie Database? So for you that don't know, Internet Movie Database is where people, there's kind of a catalog of all movies and TV shows, and people go there and they rate the movies or the TV shows, and you can go there and get information about the movies and also about how people rated it to see whether or not you might like it. So what we did, me and my undergraduate student workers, is the Internet Movie Database has a pattern to how it organizes its movies. So for instance, if I go to the Dark Knight profile of IMDb, you can see there's a number at the top, TT0468569. So what me and the undergrads did is, it turns out that this is just a number that they keep adding on to every time there's a new movie or a new TV show. So what we did is we went through and randomly selected a number, and then we went there, we figured out, we clicked on, we wrote a computer program to basically click on all of the reviews and get how many stars each user had rated. And we did this for 5,000 movies, for 2,200 individuals. So that's the data that you're looking at. Well, it's a subset of that data. I didn't want to give you all the data, and also all the data is not really useful because it turns out not everybody's seen every movie, right? So there's a lot of missingness in the data, and that causes a bunch of problems when you end up fitting models. But you could go to IMDb. So for instance, let's look at this one here, TT0110912. And you could paste that right here. And there you go, Pulp Fiction. So what we're looking at in our data set, in this column right here, is every rating, not every rating, but it's the rating from this user for that movie. Does that make sense? So user 1 gave it a 10 out of 10. User 2, user 5 gave it a 9. So forth and so on. Make sense? So we did this for, again, about 5,000 movies and TV shows. But we're going to look at a much smaller data set again because we don't have the time to run neural nets for the rest of our lives. So we're going to look at the same data set, 2,200 users, but for the 22 most ranked movies. So the movies here are very popular movies. They've been seen a lot by different individuals, and yeah. Any questions about the data? Cool. Okay, so how do I do a neural network in Jump? Because I know you guys use Jump in here a lot, right? Okay, cool. And frankly, I've done neural nets in all kinds of other software programs, and this is by far the easiest one to jump into and do some stuff and get out. So it goes a lot deeper, which as far as how to set these up and code them up. So I'm going to leave that to you if you're interested in it, because a lot of it goes even above my head. But what we're going to try to do is we're going to try to set up a neural net that predicts the rating of a user for Forrest Gump. Okay? So Forrest Gump, 1994. Here's the IMDb screenshot of it. Great movie. Highly recommend it. Has everybody seen this? Who's seen this movie? Everybody? Has anybody not seen this movie? Yes? No Forrest Gump for you? Wow, okay. So maybe if you've seen some of the other movies, maybe we can try to predict what your rating would be for Forrest Gump. You haven't seen any movies? All right, well, we would need some sort of data to get a prediction, so maybe we can. What we're going to do is we're going to set up a neural net that's going to look like this. So how many inputs do we have? How many movies do we have in our database, in our data set that we have? 22, okay. And we're using one to predict, right?